Right now, you're sitting on a bomb. Under your chair, about 22 miles of rock. Then almost 1,800 miles of white hot rock that flows like really thick honey. Then a sea of molten iron. And at the very center, a metal ball 3/4 the size of the moon, heated to the temperature of the surface of the sun. And we're somehow confident this is true, even though the deepest hole humanity has ever poked into the Earth is about 7.5 miles. That's 0.2% of the way to the center. We photographed the surface of Pluto down to 260 feet, but what's under our own feet? We figured out by listening to echoes. Literally, echoes. Here's how that happened, and honestly, the whole story is kind of insane. It starts with a tremor in Croatia, runs through nuclear bombs, and ends with particles flying through your body right now. 1906. A British geologist named Richard Oldham, a guy who'd previously been sorting through the wreckage of an earthquake in India that leveled an area the size of England, notices something off. Seismic waves from big earthquakes, the ones that should punch straight through the center of the planet and pop out the other side, show up late. Like something in the middle is slowing them down. That was the first time anyone said it out loud. There's a core inside the Earth. And almost nobody remembers Oldham. He died in obscurity. The credit went to people who came later. It happens. 3 years after that, October 8, 1909, the ground shook near Zagreb. Magnitude 5.8. Nothing world-ending, but a Croatian meteorologist named Andrija Mohorovičić got lucky. The year before, his observatory had been fitted with brand-new German seismographs and precision clocks. He pulled records from 41 stations across Europe and saw that the waves arrived in 2 batches. One set traveled along the surface, about 3.7 miles per second. The other dove deeper and came back faster, 5 miles per second. There was clearly a different kind of rock down there. Denser, harder. That boundary between the crust and the mantle? Scientists call it the moho, because nobody wants to say Mohorovičić more than once. So now we knew the crust had an edge, but what was underneath, what Oldham's waves were bouncing off, was still a mystery. 1914, a German seismologist named Benno Gutenberg notices that one type of wave, S waves, doesn't make it through the core at all, just vanishes. Quick pause here. An S wave is when material wobbles sideways. Push jello from the side, it jiggles. Push water from the side, nothing. Water doesn't hold its shape. A shear wave can't travel through liquid. So at a depth of about 1,800 miles, rock ends and liquid begins. Molten iron. Earth isn't a solid ball. It's stone on the outside and liquid metal on the inside. A candy with molten iron filling instead of cherry. Delicious. 1936. Enter the Dane. Inga Lehmann ran the seismology department at the Danish Geodetic Institute. Seismology in the 30s was a boys' club, and Lehmann was the one person in it who spent years poring over data everyone else skimmed past. She found waves showing up in the shadow zone, a region where, by every calculation, they shouldn't exist. Something inside the liquid core was bouncing them back, something solid. She wrote a paper, title, P prime. One letter, one symbol. That single symbol added another layer to the planet. It took 35 years to prove her right. They had to wait for decent computers. By then, Lehmann was long retired. She lived to 104. At 98, not a typo, she was the guest of honor at the 50th anniversary celebration of her own discovery. 4 people, 3 decades. Oldham found the core. Gutenberg proved it was liquid. Lehmann found a solid ball inside the liquid, all from vibrations, from the way the planet shakes. But here's the fair question. We're standing outside a locked house, knocking on the wall, and guessing what furniture is inside based on the sound. Are we fooling ourselves? That's where the Cold War stepped in. From 45 to 96, 5 countries detonated more than 2,100 nuclear bombs. For the planet, a disaster. For seismologists, an accidental jackpot. An earthquake has no known time or location. A nuclear blast has all of it. Coordinates, the exact second, the yield, a perfect ruler. Using Soviet tests at Semipalatinsk, scientists got their first close-up look at the boundary of the inner core. Turned out it wasn't smooth. In some spots, a sharp transition. In others, a mushy slush of iron crystals, a few miles thick. Weapons built for the end of the world helped us understand the planet. Okay then. But nuclear blasts are still vibrations, still echoes. Is there a completely different way to check? Turns out there is. In 2018, 3 physicists, Donini, Palomares Ruiz, and Salvato, shot right through the Earth. Not with sound, with neutrinos. Neutrinos are ghost particles. Trillions of them fly through you every second without touching a single atom. But at very high energies, even neutrinos start getting stuck. And the denser the stuff they're passing through, the more get caught. The Ice Cube Observatory, a cubic kilometer of Antarctic ice packed with sensors, counted how many neutrinos made it through the planet from different angles. From that shadow, they calculated the mass of the core, without a single earthquake. The result matched the seismic data. 2 methods with nothing in common. One listens to vibrations, the other catches subatomic particles, gave the same answer. Fine. So we know there's a core, it's iron, it's hot and heavy. Case closed? No, because the closer we look, the weirder it gets. In 2022, the European Space Agency converted 20 years of satellite data on Earth's magnetic field into sound and played it through 32 speakers on a public square in Copenhagen. The sound of the core. Metallic grinding, clicks, creaking, like a massive ship breaking apart in a storm. 1 million listens on SoundCloud. Creepy. 2023, 2 Australians, Pham and Tekalchik, caught waves that bounced off the center of the Earth 5 times. Inside the inner core, there's another core, a ball the size of Pluto with a different crystal orientation. Nesting dolls. Same year, Chinese researchers. The core material might be in a super-ionic state. Iron atoms locked in a crystal grid, but hydrogen and carbon flowing freely between them, like water through a sponge, solid and liquid at the same time. Previously, that kind of thing was only predicted for Uranus and Neptune. Also 2023, Yang and Song from Beijing University. The inner core slowed down around 2009 and started spinning the other way, a cycle of roughly 70 years. The previous reversal seems to have been in the early 70s. And in February 2025, John Vidal from USC added this. The core isn't just spinning back and forth. It's changing shape, getting squeezed and deformed, like a ball someone's pressing from the sides. All right, let's put this together. Inside the Earth, a metal ball hotter than the sun, spinning one way, then the other. Solid and liquid at the same time, growing unevenly, crystallizing on the west side, melting on the east, fully recycling itself every 100 million years. By some estimates, about 80,000 tons of iron solidify on its surface every second. And inside it, another ball. And by the math, it shouldn't have formed at all. For an iron crystal to nucleate in the liquid core, you'd need about 1800 degrees Fahrenheit of undercooling, which doesn't exist down there. It's called the nucleation paradox. No answer yet. The core is there, but according to physics, it shouldn't be. Without it, though, neither would we. The liquid outer core churns, generates a magnetic field. The field deflects the solar wind. The wind doesn't strip the atmosphere. Mars had a field like that once. Its core cooled. The field disappeared. The wind blew the atmosphere away. The water was gone. Red desert. That's not speculation. That's Mars Global Surveyor data. And we haven't even punched through the crust. The Kola Super Deep borehole, the deepest hole in human history, stopped at about 7.5 miles. The rock down there hit 350 degrees Fahrenheit instead of the expected 212, and it started oozing back into the hole like putty. 7.5 miles out of about 4,000. Scratching an apple with your fingernail. But we know, not completely, Not perfectly, but we know. For 120 years, people listened to the planet shake, used nuclear bombs as measuring sticks, caught ghost particles with a detector frozen into a mile of Antarctic ice, squeezed specks of iron the width of a cobweb between two diamonds, recorded the sound of what's happening 1,800 miles under Copenhagen, all to peer into a place no one can reach. The strangest place in the universe isn't out in space, it's under your chair.